All right, here's a titration problem for you. And the M1V1 equals M2V2 trick won't work here because it's definitely not one-to-one stoichiometry. And that's why I advise just don't use that at all. You're much better off with stoichiometry if you just go ahead and process the whole stoichiometric analysis. And that way you're really reinforcing all the ideas for all of these types of problems. But at the end of the day, what do I need for this is I need a balanced chemical equation. This one isn't given. So I also need to know how to write an acid-base reaction and figure out what the acid and what the base are. It doesn't give you the formula for sulfuric acid, but you need to know that it's H2SO4. That's nomenclature. You also have to know what it makes as far as products are concerned, water and a salt. And you also have to know how to form the formula for the salt that's formed. Now what we want to do is we want to balance it. Looks like I need 2 sodiums, which would give me 2 waters on the product side. Now I'm good to go. All right, the problem is asking me to figure out the molarity of a sodium hydroxide solution. All right, so what do I know? I know that there are 25 milliliters of the sodium hydroxide that was neutralized. So I know that if I need the liters of the sodium hydroxide solution, this is actually given to me in the problem. All I need to do now is figure out the number of moles of sodium hydroxide in order to calculate the molarity of the solution. So that's really my goal, is to calculate the moles of sodium hydroxide. Now, the other things that I'm given are 11.6 milliliters of H2SO4, and that the concentration of that solution was 3 molar. Again, I want to calculate the moles of sodium hydroxide, and in order to just sort this out, where am I going to start? Well, I don't start with a per expression. I start with a simple isolated unit like milliliters. So I'm going to start with milliliters of H2SO4, and I'm going to get, at the end of the day, moles of sodium hydroxide. So the first thing I do is convert milliliters of H2SO4 to liters. Then I can use that molarity from before as a per expression to do that conversion between volume and moles. Then I can use the stoichiometry in the chemical equation to calculate the number of moles of sodium hydroxide. And here's my 2-to-1 stoichiometry. When I put this into my calculator, I get 0.069 moles of sodium hydroxide. And that's, I wanted to remind myself that it is actually 2 significant figures. Okay, so now let's take this formula from before. Let's put our 0.069 moles of sodium hydroxide in the equation. Let's go ahead and crank the numbers, and I get 2.78 molar. Rounding to the correct number of sig figs, I get 2.8 molar sodium hydroxide. Just a quick correction here. This isn't solution, it's just moles of sodium hydroxide. Okay, that's it.